All right. Last part here, these 4 problems. The main thing that you need to solve these 4 problems is just your unit circle or your trig table. For these 4 problems, we actually only need our unit circle, but occasionally if you're solving for tangent or cosecant or secant, you would do the table instead. All right, let's dig in. So if you think about this problem, how would I solve it if it had said 4x minus 3 equals 0? You would be like, oh, Ms. Reidner, that's easy. Add 3 and divide by 4. So we're going to do that. We're going to add 3. We're going to divide by 4. Okay. And then I say, oh, but what if it was 4x squared minus 3? And you'd say, okay, still easy, Ms. Reidner. I just have to take the square root at the end. Yep. Okay. And then some of you are going to forget that when you take a square root, it must be plus or minus. That's important because that gives you a lot more answers. Okay. And then you're going to take the square root of the top, which is just square root of 3. And then the square root of 4 is 2. Hey, square root of 3 over 2. I think I've seen that before. So I'm going to go over here to my unit circle. And I doubt I can erase just green. But yeah, that's what I was afraid of. Okay. So looking at this unit circle here, where is everywhere that is sine, so that's the y value, square root of 3 over 2. So square root of 3 over 2 as the y value is here, 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 and here. And remember, we did say plus or minus, so all 4 of these are valid. Okay, if you don't have plus or minus, then only the positive or only the negatives are. So that is, so sine x equals this. That means that x equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, yay, 1 problem done. Next, these both have a cosine in common. So we're going to factor that out to the front so that we're left with 2 cosine x plus 1 in parentheses. Yes, you have plus 1 because if you don't have plus 1 and you distribute that back out, you can't get plus cosine x. Okay, then I'm going to split them up. Okay, so each one equals 0. So then again, go back to your unit circle. Where on your unit circle is cosine, so the x value, 0? Well, that's at pi over 2 and 3 pi over 2. Okay, and then for this half, I'm going to get cosine x equals negative 1/2. So that's subtract 1, divide by 2. Okay, so now where is cosine? Negative 1/2. So the x value is negative 1/2 at 2 pi over 3 and 4 pi over 3. So those are my 4 answers of where it happens. Oops, that was really bad. Between 0 and 2 pi, so on the unit circle. Okay. All right, number 19, I'm going to have to factor, and I'm going to use my slide and divide method. So I have cosine squared x minus cosine x minus 12. 6 times 2 is 12. So then I ask myself, what multiplies to get negative 12, but adds to get negative 1? And that's going to be negative 4 and positive 3. Okay, and then I have to go back through. So we did slide, we factored. Now I got to go back and divide. So I have to undo that slide. And I'm going to divide by the number out front. So that gives me cosine x equals minus 2/3, and then cosine x plus 1/2. Which means I'm going to set each of those equal to 0. Normally I do bottoms up, but when you're solving, bottoms up just means more steps. I could just go ahead and split these up and say, all right, cosine x equals 2/3, and then cosine x equals negative 1/2, just by subtracting or adding to the other side. Now, in this example, this is not on the unit circle, so we're not going to write any answers here. There is a decimal answer. I can do cosine inverse of 2/3 in my calculator to get that answer. I'm not worried about it. On your test, they are both nice unit circle answers after you factor, okay? All right, and then for the second one here, cosine is negative 1/2. Hey, I feel like we just did that. We did, right there. 2 pi over 3 and 4 pi over 3. Okay. And so that would be how we factor. All right, last one is a double angle formula, and I didn't even make you do any steps beforehand, so you didn't have to add, subtract, multiply, divide, any of that stuff. Notice the big difference here is that there's a 2 right here, but we're going to take care of the 2 last, okay? So we're going to do what we normally do, look at cosine on the unit circle. So where is the x value? Radical 3 over 2. And that's at pi over 6 and 11 pi over 6. Okay, now in all of the other examples, we went ahead and did x equals, and that's because x was by itself. Here, we're actually going to put 2 theta equals, because 2 theta equal. Okay, the next thing we're going to do is add 2 pi in, because what that means is those 2 places repeat every time we go around a circle. And then I'm going to get theta by itself, and I'm going to do that by multiplying everything by 1/2. Why am I doing that? Because that's the same thing as dividing by 2, and I have fractions. So then I'm going to get theta equals pi over 12 plus half of 2 is 1, so that's 1 pi in. Same thing here. Theta is going to equal 11 pi over 12 plus 1 pi in. Now, 2 of our answers are very obvious. Pi over 12 and 11 pi over 12. The rest of our answers are not as obvious. Okay, so notice these are under 1 pi. So we have only covered half of the circle. We need to cover the full circle. So we're going to do that by adding 1 pi. So that's going to be 12 over 12 pi, right? Well, 1 plus 12 is 13 pi over 12. Okay. Do the same thing here. Add 1 pi to our answer. So that's going to be 23 pi over 12. I know that I can stop there because 23 pi over 12 is almost 2 pi really. And remember, 2 pi is where we end. You're like, huh? Right there. 2 pi is where we end. So if I add any more to that, I'm going to bust. If I think about this one, it's currently over 1 pi. Well, what's something over 1 pi? If I add a whole nother 1 pi to it, that would be over 2 pi. So that would bust as well. So those are my 4 answers for the double angle formula. Okay, so these are the 4 problems for your review.